I've given you permission to record. All right. So the threat analysis, the next stage. Okay, is the next stage. Okay, where possible security threats are identified. Okay, and the risks which are associated with these threats is estimated. Okay, it's really more of what the the stage says. Okay, threat assignment. So you're going to see which threat is affecting which asset. Okay. And then we have threat web technology analysis. Okay, which available security technologies. Okay, and how can they be applied in this case, in these cases here. Available security technologies and their applicability against the identified threats are assessed. Then security requirement specification. So what you come up with at the end. So what are you going to have that is going to protect your system? Okay. Where appropriate, these will explicitly identify the security technologies that may be used to protect against different threats to the system. Okay, so here they just give you some examples of some types of security requirements. Once you've finished, okay, the different types of security requirements that will be taking care of particular areas. That's what they just talk about there. But more interesting is the example they give of LIBSYS. Now, LIBSYS is just a library system, okay, which is used in some countries. It allows controlled electronic access to copyright material from a group of university libraries, and it also allows library solutions for other campuses and specific business applications. So you can see, for example, the requirements that they came up with here. This will just give you a picture. Gives you a picture. Like requirement 1, all system users shall be identified using their library card number and personal password. So after going through the entire process, this is what you come up with. That's what they're trying to, that's the example they're trying to give here. Number 2, users' privileges shall be assigned according to the class of the user, student, staff, library, staff. So I need to get the picture here. Before execution of any command, LIBSYS shall check that the user has sufficient privileges to access and execute that command. When a user orders a document, the order request shall be logged. So you can see what happens here. Then now, if you look at 6, users shall not be permitted to have more than one simultaneous login to LIBSYS. For now, that requirement, for example, is trying to avoid it's trying to avoid when you have one login other than a user having simultaneous logins, you're trying to avoid an external attack, an external attacker. Oh, okay, hacker, can be a hacker, and any kind of adversary who uses or who copies the password that is being used at that very moment. Okay, so that you can get into the system. Okay, they didn't give another example, but then another example, which just to help you understand. Okay, from risk analysis for the hospital information system. This was for a hospital information system. Okay, now you just hear them out. You don't have to write them down. I just wanted you to understand this. You can just hear them out. So this is for a hospital information system. You can derive security requirements, and some of the examples of these are: 1, patient information shall be downloaded at the start of a clinic session from the database to a secure area on the system client. Okay. Number 2, all patient information on the system client shall be encrypted. So they're definitely trying to protect the patient information. Okay, because it can be used against, it can be used for extorting money from them and so on and so forth. Number 3, Patient information shall be uploaded to the database when a clinic session is over and deleted from the client computer, so they're not leaving a trace of any information behind. The information was pulled out to be used for sessions with the doctors or with the nurses, but then it's being cleared off from where it has been left. Number 4, a log of all changes made to the system database, and the initiator of these changes shall be maintained on a separate computer from the server. Okay, so these ones, but I was really trying to make it more clear for you through the example. All right. Okay, now let us quickly move on to the functional reliability requirements. So that was, wait, we skipped something here. So that's it for security specification. Remember, after security specification, we're moving on to reliability. Let me just get back and show you how we are moving. I won't share these slides today, so no worries there. Okay, so the next one is software reliability specification. And the ones who have just come in as I shared, I'm also going to share with you the an assignment. Oh, okay. Okay, I'm just trying to. Okay, I'm trying to do that mute thing, but it's my thing is not showing it. So it's okay. I'll see how to do it. Yes, I was saying that once I've just joined in, I'm going to share with you the assignment, and I expect it to be done in time, please. And for people to do it so that when it comes to the cut, I'm having the same people. Okay, I'm not having new people. Okay, so let's now move on to system reliability specification, of which we have hardware reliability, software reliability, and operator reliability. Okay, so hardware reliability was a probability of a hardware component failing, and how long does it take to repair that component? Software reliability, how likely is it that a software component will produce an incorrect output? And then operator reliability, definitely the operator, the human. How likely is it that the operator of a system will make an error? These are what those specify, what each of them specifies. Okay, but like now let me come to functional reliability requirements. First of all, before I explain functional reliability, someone is saying something. Yes, please. Yeah, if you could note down the names of the people taking the course, that would be very helpful, because I'll know what numbers I have. Okay, I'll know what numbers I have. Thank you. Okay. Before we go into functional reliability requirements, first of all, it's good to understand what exactly functional requirements are. Generally functional requirements. Okay, functional requirements define the basic system behavior. Okay, so it's really about the working of the system when you talk about functional requirements. Okay, they are what the system does or must do. Okay, and can be thought of in terms of how the system responds to inputs. So it's about how the system works. Okay, whereas the non-functional requirements, okay, they are about the effectiveness. They ensure they ensure the usability and effectiveness of the entire system. So not just about it working, but how effective, okay, how usable Those are the non-functional requirements. They define the system attributes such as security, reliability, performance, maintainability, scalability, usability. So that's the general difference, no matter what systems you're dealing with, even if it's not safety critical systems. That's the general understanding of functional and non-functional and non-functional requirements. Okay. So these reliability requirements, yes, there are two kinds of the functional and non-functional. Here they said a predefined range for all values that are input by the operator shall be defined, and the system shall check that all operator inputs fall within this predefined range. So you can see here it's really just about the functioning of the general functioning of the system. Okay. But then for a more direct definition, functional requirements, these are those which define the system and software functions that avoid, detect, or tolerate faults in the software, and so ensure that these faults do not lead to system failure. Okay, let me see if on which page the definition is there. Metrics. Okay, so still in that same textbook, if you go to, you check, oh, don't forget, in case the session goes off, just log back onto the same session. Someone is saying something here. Yes, I won't share. I haven't shared the assignment. I won't share it. Okay, on page 321, okay, that's where they define the functional requirements properly. So functional requirements, they define the system and the software functions that avoid, detect, or tolerate faults in the software, and so ensure that these faults do not lead to system failure. Whereas non-functional requirements define the number of failures that are acceptable during normal use of the system, or the time in which the system is unavailable for use. Okay. So you'll just check those pages there for a proper definition. Okay, because here is really just explanation. Okay. Same thing with the non-functional here. This is really explanation. Okay, the required level of system reliability required should be expressed quantitatively. They are expressed quantitatively, the non-functional requirements, and we shall see that ahead. Okay. So here it's just more of explanation of them, but for proper definition, please check on the pages that I've given you. Okay. Okay, and even before we go on, there is, okay, under the functional reliability requirements, before we go on, I want you to note this as well, that there are three types of functional reliability requirements for a system. Okay, the types of, so the functional reliability requirements are further divided. Okay, they are further divided, of which we have the checking requirements. Okay, these requirements identify checks on inputs to the system to ensure that incorrect or out of range inputs are detected before they are processed by the system. Okay, so these are checking requirements. So remember, functional requirements are dealing with the general operation of the system. And among them, I've talked about the checking requirements. Checking requirements are a very good example is the wrong frequency. if you're going to, sorry, I'm just it's an example from the from if you're working on a radio access network or a telecommunication system and you feed in the wrong frequency, some systems will automatically reject them. Okay, so you can see that's the mechanism already that is checking what you're going to feed in. We also have we have recovery requirements. These requirements are geared to helping the system recover after a failure has occurred. Typically, these requirements are concerned with maintaining copies of the system and its data and specifying how to restore system services after a failure. Okay. An example is automatic backup of routers, automatic backup of base station controllers. I'm sure at least you're familiar with routers. Okay, so the automatic backup of those ones, those are recovery requirements. Okay. Just to repeat that, these requirements are geared to helping the system recover after a failure has occurred. Typically, these requirements are concerned with maintaining copies of the system and its data and specifying how to restore system services after a failure. And once again, because here I'm really explaining, but for the proper definitions, I'm again going to refer you to the same textbook, page 328. Okay, just please take a note of these pages. I know some of the things here we may be going fast, but then yeah, we may be going fast, so I don't really have time to start dictating notes and so on and so forth. But on those pages I'm giving you, you'll find them. And then we also have what we call the redundancy requirements. Redundancy requirements, these specify redundant features of the system that ensure a single component failure does not lead to a complete loss of the service. Okay, for example, redundancy in routers, where you have two links, the working link and the protection link. That one I think is clear. The working, a protection, the standby. Okay, that's an example among the routers. I don't think they give examples there. I don't remember, but then those examples should be clear. Okay, and then yes, so those ones are important to know. Under functional reliability requirements, we have three types of those functional reliability requirements. Okay. And then let us move on to, okay. Okay, great. The notes are already available, as Moses has shared. Yes, so what you do, make sure you just take a note of these pages I'm giving you, okay? Okay. All right, let me move on. Okay, so but what we shall do, I'll still be sharing with you whatever I believe I should share with you, just so as not to miss anything, in case they are not there, in case something is missing there. But please, you can access them where you've been told, okay? You can access them there as well. All right, so reliability metrics are units of measurement of a system reliability. Okay, system reliability is measured by counting the number of operational failures and, where appropriate, relating this to the demands made on the system and the time that the system has been operational. So you will understand this definition just from the examples of the metrics. Okay, a long-term measurement program is required to assess the reliability of critical systems. A long-term measurement program is required to assess the reliability of critical systems. Okay, that's what it is. But among the metrics, we have the probability of failure on demand. We have the rate of failure occurrence. We have the mean time to failure and the availability as well. So I'm sure mean time to failure is something very common, even availability. Okay, the others may not be as common, but they're also among the among the metrics. Okay. So let me. So here they just give a brief explanation of them, but then talk about them more in detail. Just below here. Okay, so the probability of failure on demand, the likelihood that the system will fail when a service request is made. Okay. For example, a POFOD of 0.01, 1 out of 1,000 service requests may result in failure. Okay, that one is direct. And then the rate of occurrence of failure, the frequency of occurrence with which unexpected behavior is likely to occur. For example, a roll-off of 2 out of 100 means 2 failures are likely to occur in each 100 operational time units. So the operational time units really they can be varying, okay? Because when they just say operational time units, it may be abstract, okay? But they vary. The operational time units, they vary, as I will explain. Then the mean time to failure, the average time between observed system failures. Okay, an MTTF of 500 means that one failure can be expected every 500 time units. And then availability, the probability that the system is available for use at a given time. An availability of 0.998 means that in every 1,000 time units, the system is likely to be available for 998 of these. So some of these really look abstract, but then when you narrow it down to an example, then you analyze the example.